And in this example, we are running the machine learning worker with 2 replicas, but it can be changed, for example, for free. And this distributed CSS deployment is the part of the machine learning service interface. Again, all the images for this example were published to Docker Hub. So we have image ROS machine learning service distributed worker and ROS machine learning service distributed interface. And there are 2 things which have to be set as the environment variables, and this is the salary broker URL and the salary results backend. Because we are using the host network here, we can use a local host for the RabbitMQ and even for the Redis. When we are not able to use the host network, this is exactly the place where the external IP address or of the RabbitMQ or the Redis will be used, and in that case, it can be deployed over different Kubernetes cluster, and it should be able to communicate between the machine learning interface, Rabbit, Redis, and the workers will be able to connect over this IP addresses to the Rabbit and the Redis to get the tasks and to store the results. The only thing which has to be visible for the robot is the machine learning service interface. The rest of this configuration can be potentially deployed everywhere, and it should be accessible through the correct IP addresses or the correct URLs. So we have the machine learning service interface and worker, and despite that, we have even the Rabbit MQ itself, which has already published image on the Docker Hub, and to use calls to these containers, we have to define even the service for the Rabbit, which communicates over this specific port. And the same is even for the Redis, and in this context, we are running only 1 replicas of the Redis database, and again we have defined port as or we have even the service to be able to connect to the Redis server. If we take a look back to the README file, this is what I was talking about in the configuration. So the salary broker URL and the salary results backend has to be set correctly. And as I said before, each for the 4 parts described previously may be deployed into different Kubernetes cluster, and only 2 conditions have to be met. Machine learning interface has to be visible for robots wanting to process data, and correct external IP addresses or URLs has to be used for the RabbitMQ and Redis everywhere. So after we deploy this configuration, it should look like this, because we are using only one computing node, such as this virtual machine. It will be all deployed under one node, and we have the RabbitMQ pod with the Rabbit service, Redis pod with the Redis service. We will have multiple replicas of the machine learning worker and the interface itself. So I start by deploying. We are in the correct folder, and I will start deploying the distributed variant of the service. And we can watch again that all is starting. So we have the interface here, Rabbit, Redis, and I set 3 replicas for the machine learning worker. So 3 pods are creating, and we can see that some of the pods are ready now and they are running. So, okay, everything is running. I think that we can wait a few minutes or 2, because you should have ready some parts of the machine learning worker and the machine learning service interface from the previous example, but it should download the Redis and Rabbit images to be deployed. Okay, and we can again run the watch over the rows to topic list. We can see what's going on inside. Now, no topics are created now. So I will start the robot node, and again I will do ROS2 service call to the robot to start processing the data. And you can see that even the distributed variant will work. In this case, for example, in your versions running, you may see that the images which are shown back by the robot do not has to be necessary one by one, that it can maybe flick sometimes, or that it can be shown in a different order. And this is because when in that case that we are running like multiple workers, some of the worker can finish faster than the previous one, and this should be maintained in the robot node. But for the purpose of this workshop, we only present all the data which are obtained back from the machine learning service. Okay, I will stop the processing. And I will try to start even 2 robots, and we can maybe see here that there will be maybe some flickering. Okay, so I will start the first robot. And I will start even the second one. But it looks like that my host machine is powerful enough to be able to process the images in the correct sequence. So, but you can see that we are able to process the multiple robots even with this distributed application or the distributed machine learning service. So I will stop even the second robot, and I can close both robots. And the one last thing which we need to do is to clean up all the deployments and the services. So if we run these 2 commands, we will see that all the deployments and the services will be destroyed or terminated. So this led us to the end of this workshop. This is all from my side now, and now there is space for your questions if you have any. Thank you for listening.
Thank you very much for the demo. It's really, really impressive with distributed service deployed over here. So is there any questions from the audience?
it seems that it was hard enough for the people to ask questions.